sorry. What we're going to look at now is how we convert, if we're given a polar coordinate, how we can rewrite it so that it's in our Cartesian plane or our rectangular coordinate system. And then we want to be able to convert the other direction. If you're given a point in the regular rectangular coordinate system, how can we convert it so that it's into the polar? So we use what we know about SOHCAHTOA and right triangles and all of that other good stuff. We know that the cosine of theta is equal to x over r, right? So if we try to solve this for x and figure out what x is equal to, we're going to have to multiply by r on both sides. And so we get that x is equal to r times the cosine of theta. So that's where this formula is coming from. Similarly, we know that sine of theta is equal to y over r. So if we multiply by r, in this case, we get that y is equal to r times the sine of theta. So we're going to use these two formulas basically as our 2 points to help us figure out and find what, how we can convert from the polar coordinate to a rectangular coordinate. Okay, so look at how this is going to work. We're given these 2 points. We're given 2, negative 30 degrees. So to figure out how we can rewrite this using rectangular coordinates, we're just going to plug in and say x is equal to r times the cosine of theta, and y is equal to r times the sine of theta, and we're going to plug in. So we're given that r is 2, and we're going to take the cosine of negative 30 degrees. You guys asked if you needed your graphing calculators, and I goofed. I forgot we were doing this. So yeah, you do need them. Actually, technically you don't on these because we can use unit circle also, right? Can't we? Okay, to the cosine of negative 30 degrees, look up here at unit circle. Negative 30 degrees is down here, and we're looking for the cosine value, which is what? Uh-oh. What's cosine of negative 30 degrees up there at on the unit circle?
Pi, not pi.
No, not pi.
Square root of 2.
There we go, square root of 3 over 2. So we get 2 times the square root of 3 over 2. So when we clean that up, we just get the square root of 3. Similarly, if we plug in the sine of negative 30 degrees, gives us negative 1/2. And so we get that y is equal to negative 1. And so the coordinate point is the square root of 3, negative 1. Okay. All right, you can use unit circle for this the other one too. So try this one for yourself.
Oh, now I see that.
Good answer, good answer. So it will not always be the case that you can find the answer on unit circle. But if you can, I do think it kind of helps simplify the math and give you the fractions and the radicals rather than as a decimal, which you may end up doing as well. Okay? All right, so that's converting if you are given a polar coordinate to convert it so that it's into a rectangular coordinate. We also need to look last page. Guys, last page of your notes for pre-calculus.
Let's go. This is the last page.
Last page of your last note packet.
I'm confused with the...
Chris, what? Which part?
Why did we multiply by half? Like...
The cosine of pi over 3, you mean this here?
Yeah.
Cosine of pi over 3 from unit circle is a half.
Oh, yeah. I see.
Okay. All right. Are we good? Onward. Last page. Okay. So these are the directions. This is going to help us convert in the other direction. If you're given a rectangular coordinate, wow, this is really fuzzy. I'm not sure why. Sorry about that. If you're given a rectangular coordinate, how you can rewrite it so that it's in polar form, okay? So notice what the steps are here. It says, find or determine the quadrant where your point lies. So let's look at this example. If you notice this point, it's negative x value, positive y value. So you know that point is in quadrant 2. And then it says use r is equal to. So we're gonna just figure out what the radius is of, if this were a circle, or the hypotenuse, whichever way you wanna think about it. In other words, use Pythagorean theorem. So we're gonna do the square root of negative 2 squared, that's our x, plus y squared, so 2 root 3 squared. And we're gonna take the square root of that. So we get negative 2 squared is 4, plus, this gives us 4 times 3, which is 12. So we get r is the square root of 16. In other words, r is 4. So we know our coordinate point's gonna be written in the form 4, comma, and now we've got to get our angle measure. So to get our angle measure, if you notice, the last step is that we use the tangent ratio, because we have our y and our x. So if we rewrite this as a tangent ratio, so tangent of theta is y, which in this case is 2 root 3, over x, which is negative 2. If we simplify that, we get negative root 3. And so then we want to think about, in quadrant 2, at what place, at what degree measure is the tangent value equal to negative root 3. So take a look up there. Where is in quadrant 2, where is the tangent value, which is y over x, equal to negative square root of 3? 2 pi over 3, there you go. So theta is 2 pi over 3, and that gives us our second coordinate, our angle measure. Okay, should we work through the other one of that, or do you think you're good? Do you want to try it yourselves? Did you get that? 3 root 2, comma 7 pi over 4.
Oh, wait.
Tangent of theta is negative 1, and you've got to look in quadrant 4. Oh my goodness, this is already falling off the wall. I'm going to break my neck climbing up here one of these days. Will not be good. Come to my funeral, please. Promise to come to my funeral. Pay your last respects, since I'm going to kill myself trying to fix that silly unit circle.
You gotta get some good food there.
Okay.
I don't think she's gonna get the good food.